Hey guys, this is the review for your senior final. I'm going to go through some problems in each section to try to give us some guidance as far as where to go from here. The first one we'll do is number 1. And here I identify I've got a cube root function going on. It's already by itself, so what I need to do to undo that cube root is to cube both sides. And I'm going to carry this work down here. 3 cubed is going to be 27. And if I cube a cube root, they cancel each other out. We're left with 3x plus 36 on the inside. If I subtract 36 from both sides, I end up with negative 9 is equal to 3x. And then if I divide by 3, I get negative 3 is equal to x. From the same section, I'm also going to do number 3, because I'd like to talk a little bit about if we have a cube root or a square root that's not by itself, we have to get rid of the other stuff here first. Here I've got 4 times this cube root, so I'm going to divide both sides of this equation by 4. And again, I'm going to carry the work down below. We end up with the cube root of b plus 5 is equal to 20 divided by 4 is going to be 5. Same thing as before. Now I'm going to cube both sides. And I've got b plus 5 is equal to 125. If I subtract 5 from both sides, I get b is equal to 120. Continuing downwards, we've got to simplify some rational expressions and identify any restrictions on the variable. I'm going to do 2 of these ones. One is going to be based on some more simple factoring. One is going to be based on some quadratic factoring. And we're going to look at how to identify some of the answers here. First one's number 5. So we've got 6n minus 6 over 14n minus 4. This is not quadratic. However, we are able to do some factoring. The top of this, both of these have a 6 that I could take out. So that would be a 6, and then the leftovers would be n and minus 1. On the bottom, both pieces have a 14. So if I were to take a 14 out, we get n and minus 1 again. At this point, I'm going to look at my restrictions on my variable. That means I'm looking for excluded values. And in this case, whatever would make the denominator equal to 0 would be an excluded value. So n cannot equal 1. Pretty quickly, what I notice here is that based on this excluded value, if n does not equal 1, I can't use choice A or choice B or choice D. The only option is choice C. I'm going to finish off the problem and see if that holds true. I notice that I've got an n minus 1 on the top and on the bottom, so I can cancel those out, and I'm left with 6 over 14, which does in fact reduce to 3 over 7. So 3 over 7 is my answer, with n equals 1 is my only restriction. The other problem in this section I'm going to do is number 6. Here we've got some factoring both in the top and the bottom. Both of these are quadratic. The nice thing here is that we don't have any numbers in front of our k-squareds, so we can use the shortcut we've developed for factoring. For the first one, my a times c is going to be negative 36 I need to move the screen down so I can hit the top of that. Negative 36k squared. And my b value is negative 5k. So I'm trying to multiply to 36 negative and add up to 5k. Okay, negative 5k. Those numbers, so if I try that, okay, that's negative 136. Nope, nowhere near that. Negative 2 and 18, that's negative, or positive 16, no. Negative 3 and 12. It's closer, but now we're at positive 9. Negative 4 and 9 gives me positive 5. We're really close there. What if I switch those around to negative 9, positive 4? We end up with negative 5 as an answer. Those, in fact, are the numbers we need. So that means the top of this is going to factor into k minus 9 and k plus 4. All right, bottom one of these, we're looking for things. My a times c is negative 20k squared, and my b value is negative 1k. Things that multiply to negative 20 and add up to negative 1. In this case, that's going to be negative 5 and positive 4. So we've got k minus 5 and k plus 4. Again, using the shortcut that we can only use if the number in front of k squared is 1. The dogs are going nuts right now in the neighborhood because we've got a mailman walking by, and obviously that's terrifying. So I apologize for the background barking from all sides. Next up, we got to find our excluded values. So our excluded values are going to come from the numbers that make the denominator equal to 0. In this case, we've got k cannot equal 5 and k cannot equal negative 4. Just like before, the problem we just did, if I take a look at my excluded values, the only one that has those is answer choice D. So in fact, that has to be the answer. I am going to finish off the problem to make sure that's true. K plus 4 and k plus 4 both can cancel out, and we're left with k minus 9 over k minus 5 as our final answer, which happens to be the other part of D. The next problem we're going to take a look at is on our next page. First thing we got to do is identify any vertical asymptotes for the radical functions, or for the rational functions we have here. And I'd like us to remember that vertical asymptotes happen when the denominator is equal to 0. So for this guy, I'm going to write the denominator, x squared minus 2x minus 3 is equal to 0. And by golly, that looks factorable. In fact, it is. So I'm looking for things that multiply to negative 3 and add up to negative 2. That's going to be x minus 3 and x plus 1. Okay, that means I have x equals 3 and x equals negative 1. Those are both vertical asymptotes. We haven't graphed anything with more than one vertical asymptote, but we certainly could. And in this case, we're just trying to find them. So once you've identified both of those numbers, you're done with that problem. Next up, we've got to find some inverses. And in doing this, we're looking at some linear functions. I'd like to remember that when we have a function we're trying to find an inverse of, we're going to write this as a y equals. So we got y equals 5/9 x minus 20 over 9. By the way, I'm going to show you a cool trick in a minute, which I could rewrite as x equals 5/9 y minus 20/9. So I've got to switch my variables. The big thing about inverses is that they switch variables. The cool thing that I noticed as I was writing with this is I've got two things that both have a 9 in the denominator. I'm going to kind of break my algebraic form, which is normally to do reverse PEMDAS, and multiply my entire equation by 9. We're going to see something pretty cool happen with this. So we get 9 times x is 9x. 9 times 5/9 makes that 9 cancel out, so we don't have a fraction anymore. Now we just have 5y. 9 times negative 20/9, again, just cancels out that denominator, and we're left with minus 20. This is a great way to get rid of denominators early in a problem so that you're less likely to make mistakes a little bit later. Okay, finishing this up, we're going to add 20 to both sides. So we get 9x plus 20 is equal to 5y. And then we're going to divide both sides by 5. And I'm feeling kind of lazy, so that's okay. We're not going to divide this out yet. I'd like to talk about the fact that none of my answers look like this form. And in looking here, I've got things that have ninths in the bottom, not something without a fraction, something with some numbers and some fractions, with thirds and with seconds, or halves. The first thing I'm going to notice is that if I'm dividing by 5, the only thing that I could have as an answer is if we have a whole number, because if those come out nice, or maybe if we have a 5 in the bottom, like in this guy. I can't just turn fifths into ninths, so I can cross out, oh, that's my original problem. I'm going to see if I can get rid of those two x's. So I can't end up with thirds because that's not the same thing that I'm dividing by. I can't end up with a half. So I'm limited to one of these two things. The second piece of this is that if I were to divide this out, so that means, right, this is 9x over 5 plus 20 over 5. Hopefully we can see that the one this looks the most like already is b. And it's going to look even more like that when you realize that 20 divided by 5 happens to be 4. B is the answer for this problem. The next problem that we're going to do on here is going to be number 15. Okay, so we've got to figure out which of these is equivalent to this expression. What I've got to realize here is that this rational exponent can be distributed to both of these pieces, and then we can work with that. So we've got 81 to the 3 halves times x, and we're going to multiply these two. 4 over 1 times 3 over 2 is going to be 12 over 2, or 6. And really quickly, I see that choice A, choice C, and choice D cannot be correct because they don't have an x to the 6th power. The only one that does is B. Let's talk about why that's true. Okay, so we're done with our variable part. Now let's talk about 81 to the 3 halves. 81 to the 3 halves, I'm going to rewrite as a radical expression. The half on the bottom makes this the square root of 81, and then we're going to have that to the 3rd power. In looking at this, the square root of 81 we know is 9, and 9 cubed is going to be 729. That's where this 729 comes from. If you aren't sure how to do that, one thing that you could do on your TI graphing calculator is type in 81. If you use the caret button, it looks like this. That's going to give you an exponent. We need to use parentheses, but then we could do 3 divided by 2 in parentheses. And that'll give you 729 also, without having to write that out. And the next problem that we're going to do is on the next page again. So I'm just going to zoom out so I can leave this as a full screen thing if you'd like to keep all 3 of these open, and move on. Here we're looking at graphing square root functions, and we're trying to figure out how to build a table for this and identify the correct function with the domain and range. I'm going to start by building a table. We know for square root functions, and this is for number 19 by the way, that what we're trying to do is choose nice values that make us able to have a whole number when we take the square root. And I'm going to start by trying to make the inside 0, so that's going to be an x value of -2. -2 plus 2 is going to be 0. The square root of 0 is 0. As soon as I have that point, I'm going to take a look at my graphs. You don't necessarily need to do this right away. You could get some more points first. But if I look for a graph that has -2, 0, which is right there, okay, no. Or right there, yep. Right there, nope. Right there, yep. Okay, we're looking at only 2 possible answers now. So what we've done is we've crossed out 2 of our answers by only finding a single point. The next thing I might try to do is make the inside 1. So that's going to be -1 because -1 plus 2 is +1. If I do the square root of 1, I get 1 as an answer. So we're looking at -1, 1. That's a little bit harder to see on my graph. But what you might realize is that we're looking at something that looks very much like this, which, in fact, both of those do. So the other differentiation piece I need to look at here is the domain and the range. The domain of this, x starts at -2 and is getting bigger from there, so x is greater than -2. Both of those have that in the domain. For the y, I'm starting at 0 and I'm going up, so y has to be greater than or equal to 0. This one is less than. That one doesn't work anymore. So I'm left with answer choice D is my final answer. This is the only problem on this page that we're going to do, so I'm just going to zoom out and move on. We're also not going to do any problems from this page because they're very similar to the ones we just did. I'm just going to center this and move on again. Next up, we've got some working with rational exponents. I'm going to do number 24. Looks like it's harder than some of the other ones, so let's do that one. Okay. First thing I notice is that I've got an exponent sitting outside of the parentheses in the bottom. So I might rewrite this just as, and I'm going to put an a to the 1 so I don't forget that that's there, b to the 2/3, and then the bottom we're going to have 4/3 times 3/2. 4 times 3 is 12. 3 times 2 is 6. That's going to be a to the 12/6. And you might say, Mr. Carlson, I know 12 divided by 6 is 2, and you'd be right. If you want to simplify that to get a squared, you're absolutely welcome to do that. In fact, I highly suggest that you do that. It's a great strategy. Second piece of this is going to be b to the 3/2 to the 3/2. So 3 times 3 is 9. And then we've got 2 times 2 is 4. So that's going to be 9/4. Okay, step 1 is done. I've now multiplied that through to simplify our exponents a little bit. Next thing's next, I got to treat these guys with exponent rules. We're dividing, so what we're going to do is subtract our exponents. So we've got a to the 1 minus 2 and b to the 2/3 minus 9/4. Okay? With the first one, we get a to the -1. I'm going to talk about what to do that negative in a minute. And then for the second one, we've got to deal something with our common denominators. Because I can't subtract those until they're common. I'm going to multiply the 1 left by 4/4 and the 1 on the right by 3/3. And I end up with b to the 8/12 minus 27/12. Okay? So we end up with a to the -1, b to the 8 minus 27 is -19/12. Negative exponents are going to end up on the bottom of fractions. So what we do here, instead of a to the -1, I'm going to write this as 1 over a to the 1, or just 1 over a. B to the -19/12, I could write as 1 over b to the 19/12. Or if I really wanted to make this a little bit simpler, I could write them both on the bottom. So we got ab to the 19/12. Can't really see that 12 there, so I'm going to rewrite that. And then we're going to zoom out to see what's next. Ooh, we got to perform some indicated operations. That sounds like some function problems. Taking a look at number 27, that's exactly what's going on here. Okay, here we're trying to find f of g of 10. This means I'm going to plug in 10 to the function g, and then whatever I get, I'm going to use in my function f. First thing I'm going to do is to find g of 10. G of 10 means I'm plugging in 10 to the function g. So 2 times 10 plus 2, which is 22. Okay? Now I'm going to use that in the function f. So f of g of 10 is the same as f of 22. So f of 22, now I'm going to use the function f. Is going to be 22 plus 2, which is 24. That happens to be choice B. Going to scroll down a little bit, and we're going to look at 31, which is based on finding an inverse relation. I'd like us to recall that inverses are where we switch our x and y. Usually, when we see these, we're used to seeing this in a table or a graph. If you'd like to make this into a table, you're welcome to do so, although you certainly don't need to. So that'd be 2, 1, 4, -5, 1, 1, and 9, 0. Okay? The inverse for this would be 1, 2, -5, 4, 1, 1, that's interesting, that one stays the same, and 0, 9. The inverse for this is just flipping the x and the y coordinates. If it's helpful to you to make a table first and then convert that to coordinates after, that would be fine, but you certainly don't need to do that. I'm just going to zoom out and move on to the next page of the review. Next up, we got to perform some more function operations. And here, it looks like we're doing some subtracting or some adding. So I'd like to interpret this. So f minus g of x is the same thing as f of x minus g of x. In other words, negative 3x minus 2 minus negative 3x cubed plus 2x. What this really is a combining like terms problem. So we've got negative 3x and positive 2x being subtracted. Negative 3 minus 2 is negative 5x. We've got a minus 2 with nothing to go with it, so I can just write that. And then minus negative 3x cubed is going to be plus 3x cubed. If you'd like to rearrange that, you could also write this as 3x cubed minus 5x minus 2. But if you're just doing this for a free response type question, you do not need to do that to get full credit. Next up, we're going to look at 37, which is doing some division. Actually, I'm going to do, 38 looks better. That looks harder, so let's do that one. 8n to the fourth minus 15n cubed minus 21n squared minus 16n plus 2. We've got an n minus 3 on the outside. First things first, I'm going to check what do I have to multiply n by to get to 8n to the fourth. And that's going to be 8n to the third. From there, I've got to multiply. So we're going to multiply down. We get 8n to the fourth. And multiply there. In other words, distribute to both of those. Minus 24n to the third. And after we check and multiply, we're going to subtract. We're going to do the same 3 steps every single time. And when we do that, I like putting parentheses around this just to cover my rear as far as making sure I don't lose negatives. And I'm going to do that here if I'm not careful. First thing should be 0. Negative 15 minus negative 24 is going to be positive 9n cubed. And then finally, I'm just going to bring down that negative 21n squared to help me with my next step. I'm going to go back to the beginning. I'm going to check. So what do I multiply n by to get to 9n cubed? That's going to be a positive 9n squared. After I check, I'm going to multiply. I'm going to multiply that, and I get 9n cubed. I'm going to multiply here, and I get negative 27n squared. Again, I've got to be really careful subtracting. I've got lots of negatives going on here. So when I go to subtract, I'm going to put parentheses around that. We get 0, and then negative 21 minus negative 27. That's really adding 27. We get positive 6n squared. And then finally, we're going to bring down the minus 16n. Okay? I'm going to go back to the beginning. I'm going to check. What do I multiply n by to get to 6n squared? That's going to be plus 6 and an n. From check, I go to multiply. I've got to multiply by n, and I get 6n squared. I've got to multiply by negative 3, and I get negative 18n. This is the problem that keeps on giving as far as negatives go. We're going to subtract. Again, I'm going to be really careful when I subtract with those negative numbers and use parentheses for that. And when I do subtract that, I get 0. And I get negative 16 minus negative 18 is positive 2n. And finally bring down my plus 2. Whew, one last go around. I've got to check again. N times something equals 2n. That something is 2. And then I'm going to multiply again. 2 times n is 2n. 2 times negative 3 is going to be minus 6. And then I'm going to subtract again. Again, I'm going to be really careful because once again I ended up with a negative at the end. Ugh. And in doing this, we end up with 2n minus 2n is 0. 2 minus negative 6 is going to be 8. Since that's a number, that's going to be my remainder. The very last thing I need to do is to write that as 8 over my divisor, n minus 3. Let's zoom out and move on to our next page. We've got some rational functions here. We've got to identify vertical asymptotes, x-intercepts, y-intercepts, horizontal asymptotes, and then sketch the graph. That's crazy. Let's look at 41 for this purpose. So vertical asymptotes. I know that happens when my denominator is equal to 0. So in looking at this, we're going to do x plus 1 is equal to 0. That means that x equals negative 1. As soon as I see that, I'm going to add a vertical asymptote to my graph at x equals negative 1. X-intercepts. We came to an understanding of this that let us do a shortcut that says we're looking for when the numerator is equal to 0 for most of these functions. So if 3x equals 0, that means that x equals 0. Okay? Y-intercepts. That's going to happen if I plug in 0 for x. So if I do that, we get 3 times 0 over 0 plus 1, which happens to be 0. Oh, wait, we kind of already put that on the graph. And then finally, we've got a horizontal asymptote. And one of the ways we did this was to plug a really big number in. I'm going to use 10,000. So we get 3 times 10,000 over 10,000 plus 1. If you were to do this out, you end up getting a number really close to 3. That means my horizontal asymptote is going to be y is equal to 3. Another way to look at this is if I can ignore this number, 3x divided by x is equal to 3. That will always work as far as telling you your horizontal asymptote. As you get really, really big, the numbers that don't have an x don't matter anymore, and you can just divide those x values to get where you need to go. So in this case, you've got a horizontal asymptote at y equals 3. Okay, finally, we've got to sketch this graph. And in sketching this graph, we're going to use this point to make a nice curve on this side. And then we're going to make a reflected curve in the opposite corner of my asymptotes. So we've got to use the point to help us figure out where our curve should be. And then we're going to use the opposite corner to draw our other half. Sometimes you'll end up with points on both sides, so you can do it a little bit more easily. In this case, we only had one point that showed up because the x and the y-intercept both happen to be the same value. Finally, here are the answers. If you'd like to take a look at the problems here and use this as a guide for the answers to these problems, that should put you in a pretty good place. I'd like to remind you that for this final, you're allowed a reference sheet that's 1 page. Eight and a half by 11. You can use both sides. It has to be handwritten, and it can't be copied. I would probably put enough stuff on there to get you through any problem on this review. I'd like to remind you again that in making this review, we went through the test and tried to put examples that were really close to the problems on the test, so that if you were to, let's say, do the problems on here, you should be in really good shape for the final.